Welcome to this quick content enhancement video for SSH CryptoAuditor, a central management appliance which has the ability to monitor, audit, and control SSH, SFTP, and RDP sessions without having to deploy agents or change the user experience. I'm Jimmy Mills, and I'm a Senior Solutions Engineer at SSH Communications Security. It'll be my pleasure to show you how CryptoAuditor can solve important issues around privileged access and accountability within secure shell environments. CryptoAuditor comes as a virtual or hardware appliance with a centralized management instance referred to as a vault, along with distributed data capture units called hounds. These hounds can support various operational modes. With this architecture, it allows an enterprise to place hounds in locations where data needs to be captured without making any changes to network topology. CryptoAuditor Vault acts as a central storage for all audit trails so you can have centralized visibility across all connections in your environment. Furthermore, the whole solution can be connected into other enterprise security tools such as a SIEM, identity management, data loss protection, and intrusion detection systems. Hounds capture the traffic for auditing and control purposes. There are 3 operation modes that allow hounds to imitate various network devices for transparency and flexibility. The 3 modes are Bridge, Router, and Bastion. A CryptoAuditor deployment can, and in most cases, consist of one vault with multiple hounds, which in turn can be configured for high availability. By default, each vault comes with a built-in hound. The solution comes with a web user interface which can be accessed by your admins to view reports, investigate incidents, and define policies. The policy engine itself is the heart of the solution, where you can set up simple to complex rules depending on the connections you want to capture for restrictive and/or auditing purposes. CryptoAuditor administrators can define connection rules which determine the auditing actions and access restrictions that are applied to the captured sessions. Each connection rule has criteria that define what kinds of connections it is applied to. When a captured connection meets the criteria of a certain connection rule, that rule would then be applied to the captured connection. The applied rule determines what actions are performed on the connection and its contents. CryptoAuditor iterates through the connection rule list in a descending order and applies the first matching rule to the connection. Therefore, in cases where the CryptoAuditor system contains multiple rules that can successfully match to a particular connection, the matching rule that is highest up on the list will be applied. If none of the rules match to the connection, then CryptoAuditor defaults to relaying the connection to its destination without performing any auditing or access control on that connection. Now let's view how the solution works. I have a policy rule already created which will capture SSH traffic going to a host group called UKM backends. I am not redirecting the destination, but I am altering the client to hound authentication. In this case, I am authenticating with an LDAP account, and from there the LDAP account is mapped to the root account on the target machine. The auditing actions are set to store shell sessions, SFTP, and remote executions, but to deny tunneling and X11. As I open a SSH terminal session, I'll first specify the IP of the UKM backend. And instead of specifying root, I'm going to plug in the LDAP account Alice and AD. When I click to connect, it'll prompt me for Alice and AD's LDAP password. When I plug that in, it'll automatically redirect me to root on the UKM backend itself. We can go in to the home page and we can see the current connection. And from there we can actually see that this connection utilized the rule audit UKM admins. Now if we want to go back in, we can look at a different rule. This rule does not change the end user experience. When they perform their connection, it'll go directly from the client all the way to the target machine. So they will not see any changes with how they authenticate currently to the server. All the auditing actions are still the same. I'm monitoring for shell, remote execution, and SFTP. Notice the SFTP that I'm storing the full session. Any files that I transfer are going to be stored through CryptoAuditor, where I can go back and review later on. I'll show you how that works. We'll do a quick connection. to another host that I'm logging in directly as root. As I get connected, I'm going to take this test1 file and I'll show you what the test1 file currently looks like. Let's open that up. The only contents I have in there are this as a test. I'm going to transfer test1, and as we can see, it completed successfully. I can go back in to the home page where I'm going to see this session. I'll click on it, which will take me back to the trails and logs. When I specify more details, I can see the file that was just transferred. I can then download that file to my workstation to where I can view the contents of that file. This would be good in situations where you believe that somebody transferred a file externally with confidential data. The next scenario that we can look at is how DLP will work with CryptoAuditor. This other file, test2, contains the text of top secret. DLP is currently configured to block any and all traffic with the words top secret. Now if I come back in and I try to transfer the test2 file, it says completed, however the connection was lost. And even though it does show that it was completed, if I come in and I connect in to that host itself, we can cat the test2.txt file. As you can see, this file has no contents in it. This is just a good example of how CryptoAuditor can enforce the policies that DLP has in place. This concludes today's demo. We at SSH Communications Security appreciate your time.